One thing just about every game needs is a loading screen. There are a lot of ways to make one, but today we're going to make a simple but effective loading animation with a fade effect. Let's get started. First, let's create a scripts folder. Inside, create a new script and call it Loading Manager. This is where we'll control everything from. Next, create a new game object and call it Loading Manager and add our new script as a component. Right-click on the cog, select Edit Script, and we're ready to write our Loading Manager. Now, let's make our Loading Manager a singleton, meaning we can use it from anywhere, but we're only able to make one of them. This is a quick and dirty way to make a singleton, so if you're interested in learning more, then check out my other video on the topic. I'll leave a link in the description. With a singleton, we access the class through a static instance variable that we can make by typing public static loading manager instance. Inside awake, we check if our instance is null. If it is, then we set our instance to this. We also call don't_destroy_onLoad, passing in our loading manager so it doesn't get destroyed when we change scenes. Next, let's add using Unity Engine.scene management to the top of our script. Now we can add a load scene method with the scene name as a string as a parameter. Inside, we call scenemanager.loadScene, passing in our scene name parameter. Now let's make our new scene. Go to our scenes folder, right-click, create new scene, and let's call it scene 2. Inside, I'm going to add a background I prepared earlier. Whenever we want to load a scene, we need to add it to the build settings. Let's do that now by clicking File, Build Settings, and dragging in Scene 2. Now that we've got our second scene, let's add a button to take us there when we click on it. Open up our sample scene, right-click, select UI, and Button. This will make a canvas automatically for us with a button object as a child. Let's change the text to Next Scene, and we'll just move it over here to the right a little bit. Now, let's have our button call our loading manager's load scene method when we click it. Under the button script, let's go to onClick and click the little plus sign. Next, we'll drag in our loading manager and click on Loading Manager and Load Scene. In the text box, we'll type in Scene 2 as our parameter. Now, if we press play and click on our next scene button, we can see we've changed to our second scene. Next, let's create our loading screen and have our loading manager display it when we change scenes. Select our loading manager and right-click, select UI and Image. This is going to be the background for our loading screen, so let's call it Loading Panel. Let's set the color to something close to black and resize it to 1920 by 1080. Now, on our loading panel, let's right-click, select UI and TextMesh Pro Text. When prompted, import the TextMesh Pro Essentials. TextMesh Pro is an officially supported package. It's really similar to the default Unity UI, except it adds a lot more options for us. When that's finished, let's change the text to loading, make it bold and italic, and we'll select this AB down here to make it all capitals. We'll also set the alignment to centered for both horizontal and vertical. Finally, we'll set the canvas sort order to 1, so our loading screen always draws on top of our next scene button. Now that we've made our loading panel, let's modify our loading manager to toggle it on and off. Let's add a variable for the panel by typing public GameObject loading panel. Inside awake, we'll disable it by calling loadingPanel.setActive and pass in false. Before we load our new scene, we'll activate the panel, and after we've loaded it, we'll deactivate it again. Currently, our call to load scene will freeze the program until it's complete. We want to change this so that it loads over multiple frames and we can do other things while we wait. Luckily, we can do this easily with a coroutine. First, let's add a private string variable called targetScene. Inside our loadScene method, we'll set our targetScene to our parameter and then loadScene targetScene. Next, we'll create our coroutine by typing private IEnumerator loadScene routine. Now, we'll copy our code from loadScene and paste it into our loadScene routine. Inside, we'll change loadScene to loadScene async and create an async operation variable called op, which will be returned by this method and tell us about our target scene's loading state. Finally, while our operation is not done, meaning our scene hasn't loaded, we'll yield return null. Now this might look like some scary syntax, but it's not too complicated. A coroutine is a special kind of function that can be broken up into multiple steps. Once per update, the coroutine gets called and continues where it left off. It keeps running until it runs into one of these special yield return statements. Now, back in our load scene method, we'll start our coroutine running by calling start coroutine and pass in our load scene routine. Back in the editor, let's select our loading manager and drag in our loading panel. Now when we press play and click on our next scene button, we can see our loading screen appear, but only for an instant. We need a way to make the loading screen stay for a while so it doesn't look rushed. Now let's return to our loading manager script and add a public float min load time. In our load scene routine, while our scene is loading, let's write float elapsed time and set it to 0. While we're loading, we'll increment this value by time.delta time. Once we've finished loading, We'll add another loop as long as our elapsed load time is less than our min load time. And inside the loop, we'll again increment our elapsed time by time.delta time and yield return null. Now let's go back to the editor, select our loading manager and set our min loading time to 2. Press play, click on next scene, and we can see our loading screen now stays for 2 seconds before disappearing. Next, let's animate our loading screen by adding a rotating image. This could be a loading wheel, a logo, or really anything else from your game. Select our loading panel, right click, select UI, and image. Let's set its image. You can choose any image, but I'll be selecting a loading wheel. Let's also move our text a little bit up and our image a little bit down. Now, let's change our loading manager to spin our wheel. Add a public game object loading wheel, and we'll also add a public float wheel speed. Our wheel is going to be rotating in a separate coroutine, so we'll also add a private bool isLoading to keep track of our loading process. At the start of our load scene routine, we'll set isLoading to true, and then at the end, we'll set it back to false. Now we'll create a new coroutine by typing private IEnumerator spin wheel routine. Inside, we'll loop as long as we're still loading. Then, we'll rotate our loading wheel on the z-axis. We want it to rotate clockwise, so we'll rotate by negative wheel speed. And then, yield return null. Back in our load scene routine, after we activate our loading panel, we'll call start coroutine spin wheel routine to start the spinning. In the editor, let's select our loading manager and drag our wheel into the loading wheel slot. We'll also set our wheel speed to 2 and press play. When we click on next scene, we can see our wheel spins. So we've got our loading screen animating, but it still looks a bit out of place having it just pop up immediately. Let's smooth things out a bit by adding a fade effect. Select our canvas, right click, select UI and image. Let's rename it to fade and set the color to black. Resize it to 1920x1080 and then we'll disable it. Back in our loading manager, let's add using UnityEngine.ui to the top of the script. We'll also add a public image, fade image variable, as well as a public float fade time. Inside our awake method, we'll deactivate our fade image. Next, inside our load scene routine, before we activate our loading panel, we'll activate our fade image and set the alpha on its canvas renderer to 0, or fully opaque. Now let's write our fade method by typing private bool fade with a float parameter representing our target alpha value. Inside, we call fadeImage.crossFadeAlpha, passing in our target value, our fade time for the duration, and we ignore the timescale. This will move our fade image's alpha value one step towards our target. Next, we check if the absolute difference between our fade image's alpha and our target is less than 0.05. If it is, then we're just about done. So we set our fade image's alpha to the target and then return true to indicate that the fade is finished. If we're not close to our target, then we need to keep fading, so we return false. Finally, let's implement our fading sequence. First, before we activate our loading panel, we need to fade to black. So we loop while fade 1 is not true, and then we yield return null. After activating our loading panel, we need to fade back out. So we fade 0, and again wait until that's done. For the third one, we need to do it once our target scene is loaded, we need to fade to black again. And then the last one is once we've turned our loading panel off, we need to fade out to reveal our destination scene. Back in the editor, let's select our loading manager, drag in our fade image, and set the fade time to 0.3. If we press play and click on our next scene, then we can now see our entire loading sequence in action. That's about it for this video. There is a lot more we can do with loading screens, so if you'd like to see a more in-depth video, or a video on any other topic, let me know in the comments below, and thanks for watching.